Your car payment is never just a car payment. The moment you sign that contract, 3 other bills show up uninvited. Insurance climbs every renewal. One repair bill wipes out 3 months of savings, and the day you try to sell, the number on that screen makes your stomach drop. For a man living on a fixed pension, that is not an inconvenience. That is a threat to everything you spent 40 years building. Here is what most reviews will never tell you. The Tesla Model 2 was not designed to be fast. It was not designed to be flashy. It was designed specifically to kill those 3 bills before they ever find your wallet. Today, I'm going to break this car down the way an engineer looks at a machine, not to impress you, but to protect your money. I will tell you exactly what is confirmed, what is reported from credible sources, and what is still estimated. No hype, no pressure, just the technical truth. Stay until the end because the final section redefines what the word cheap actually means, and it may change how you think about every car you ever buy.
Smaller body, more space you actually use. Let me start with a number that surprised me when I first ran across it. Based on reported design specifications, the Model 2 is roughly 230 millimeters shorter than the Model 3 and about 80 millimeters lower. On paper, that sounds like less space, but Tesla reportedly increased real usable volume by an estimated 20%, with projected cabin and cargo capacity around 2,450 liters. How? Because they did not just shrink the car, they reallocated space. Most sedans waste volume in the roofline and behind the rear seats. A redesigned roofline and steeper hatchback angle pushes usable depth where you actually store things. Smaller outside, bigger where it counts. Seats, legroom, cargo. Now here is the part that matters if you have knee or back issues. According to reported engineering data, the front doors open about 1.15 meters wide at roughly a 37-degree hinge angle. Inside, reduced seat thickness and a trimmed dash reportedly add around 42 millimeters of knee room. That may sound small, but in ergonomic terms, it's the difference between stepping in cleanly and twisting your hip every time. For anyone with a bad back or knee history, that's not comfort, that's injury prevention. The other number worth knowing is the estimated turning radius, about 5.15 meters versus roughly 5.3 meters on a Mazda MX-5. That suggests the Model 2 could be easier to place in tight lots and narrow streets. Combined with an estimated weight under 1,450 kilograms, it should carry less inertia in stop-and-go traffic, which translates to lower energy use. And lower energy use means lower charging cost, every single month. The Model 2 is not trying to impress you with size. It's trying to stop you from paying for space you never use while protecting the comfort you actually need. But getting the interior right is just the beginning. The real savings are not in how the car feels, they're in how the car is built.
Where cheap actually lives, inside the factory. Here's a question no car reviewer ever asks. What does it actually cost to build a car? Not the sale price, the build cost. Because the gap between those two numbers is where manufacturers hide their margin, and where you, as the buyer, eventually pay through hidden repair costs, poor materials, and premature wear. Based on reported supply chain information, Tesla is doing something structurally different with the Model 2 at the manufacturing level, and it matters directly to your wallet. Start with the body structure. Tesla is reportedly developing a new alloy that combines steel, aluminum, and manganese, a material mix designed to balance durability, weight, and production cost. This combination is estimated to reduce body weight by approximately 8%, which is around 45 kilograms less than a comparable steel body. And in electric vehicle engineering, weight reduction is the single most efficient lever for range improvement. Industry research from independent automotive engineering studies, not Tesla marketing, consistently shows that reducing vehicle weight by 10% improves energy efficiency by roughly 8 to 6%. That means less battery capacity needed for the same range, which keeps production costs down without shrinking the usable miles per charge. Now here's a number that deserves more attention than it usually gets. The new material reportedly increases body stiffness by approximately 15%. Estimated testing data suggests the frame reduces deformation by about 20 Newton meters per degree of torsion. A stiffer frame means the suspension does its job more accurately, the steering returns clearer feedback to your hands, and the doors stay aligned for longer. A frame that flexes less rattles less, and that rattling, that creaking, that door that starts sticking after 2 winters, those are the early warnings of a car quietly degrading in structural quality. Here's something the automotive industry does not advertise. Dealership service departments make a significant portion of their revenue from exactly those small recurring failures: rattles, squeaks, seals that let moisture in. The Model 2 is reportedly engineered to suppress that process before it starts. That is engineering against the service bay, not for the showroom. But the most aggressive cost-cutting move Tesla is reportedly making is one most people have never heard of. Traditional automotive paint, the multi-layer process every car you've ever owned went through, can reportedly cost up to $3,000 per vehicle to apply. It requires massive temperature-controlled spray booths, dozens of chemical layers, extended curing time, and enormous energy consumption. Tesla is reported to be developing a technology called dry coat finish, which uses a metallic vapor deposition process. Instead of spraying chemicals onto the surface and baking them in, this process reportedly bonds metallic coating directly to the alloy at a molecular level. The estimated result, approximately 40 kilograms of CO2 eliminated per vehicle during production, significantly shorter finishing time, and a surface that is structurally harder than traditional polymer paint. When color is integrated directly into the material rather than applied on top of it, it is estimated to resist scratches better, hold up against UV exposure longer, and not peel or fade the way standard paint does after years in the sun. For someone who parks in a driveway in Florida or Arizona, that's the difference between a car that looks 10 years old at year 4 and one that still holds its finish at year 8 without expensive paint correction. And a car that holds its finish holds its resale price. That's money back in your pocket when you decide to sell. Cutting the paint process isn't cutting quality, it's cutting cost at the factory while delivering a surface that performs better over time. Now let's get into the details that most reviewers completely ignore, the small components you touch every single day that when they fail cost you far more than their size suggests.
The small things that drain your wallet quietly. There is an old rule in mechanical engineering. The component that fails most is not the most complex one. It is the one you use the most. Think about your current car. What do you touch more than anything else? The door handle. Every single day, multiple times, in heat, in cold, with wet hands, with gloves on. Most vehicles treat the door handle as an afterthought. Based on reported design direction, Tesla is treating it as a primary reliability target on the Model 2. According to reported specifications, the Model 2 reduces door opening force from approximately 30 newtons down to 18 newtons. That is a 40% reduction in the mechanical stress placed on the handle mechanism with every single use. Less force means less wear on the internal components, less stress on the mounting points, and a longer operational life for the entire assembly. Reported cold weather testing data shows the Model 2 door handle maintains stable operation in an estimated 980 out of 1,000 open and closed cycles at -5 degrees Celsius. The Model 3, under similar reported conditions, reaches approximately 170 cycles before performance degrades. That gap is not a minor improvement, it is a fundamental redesign. I want you to pause on that number. 170 cycles versus 980. If you live in Minnesota and open your car door twice a day from October through March, that is roughly 360 cold weather cycles in a single year. Under reported Model 3 performance, your handle is already degraded before spring arrives. Under the reported Model 2 design, you are still well within range after nearly 3 full winters. That kind of engineering never shows up in a comparison review, but it shows up very clearly on your repair bill. Tesla is also reported to have reduced the number of moving parts inside the door handle mechanism from 9 components down to 5. Fewer moving parts means fewer friction points, fewer potential failure locations, and lower replacement cost when service is eventually needed. And here's the calculation that actually matters. If a door handle failure on a modern vehicle with embedded electronics costs anywhere from $400 to over $800 to repair properly at a dealership, and that failure happens twice in a 10-year ownership window, you have just spent $1,600 on a piece of hardware most people never even think about at purchase. Now let us talk about the mirrors, because most drivers do not realize how much those 2 side mirrors are quietly costing them every year. The Model 2 reportedly increases surface area from 35 to 39 square inches, which expands the driver's field of vision and reduces the blind spot angle to an estimated below 1.9 degrees. At highway speeds, detecting a vehicle in your blind spot 0.3 seconds earlier is the difference between a smooth lane change and an emergency swerve. That is not a comfort feature. That is an accident prevention feature. And preventing one collision, even a minor parking lot scrape, saves you between $800 and $4,000 depending on the damage. But there's also an energy efficiency angle most people overlook. At highway speeds above 60 miles per hour, aerodynamic drag accounts for more than 60% of total resistance. The Aeroflow wheel covers extend this further, improving overall efficiency by an estimated 5.4% and adding roughly 22 to 25 kilometers per charge cycle. Over 5 years of ownership, those small gains stack into a real number on your electricity bill. This is the engineering philosophy that separates a machine designed to look good in a showroom from a machine designed to cost less to own after the cameras stop rolling. Small savings stacked systematically compound into financial protection. That's what the Model 2 is reportedly built around. And that brings us to the chapter most YouTube channels skip entirely because it requires you to think about what you are not buying and why that protects you. The philosophy of enough. Why not chasing the newest technology protects you. Here is a sentence that goes against everything the technology industry wants you to believe. The most expensive car to own is often not the cheapest car to buy. It is the car that forces you to upgrade, update, or replace major components just to keep it functional a few years after purchase. Tesla reportedly made a very specific decision with the Model 2 that most people criticize without understanding. They did not build it around their newest and most powerful chip. The AI-5 processor, Tesla's next-generation autonomous driving computer, is reported to enter pilot production in 2026 with limited output and is not expected to reach large-scale production until 2027. New generation chips in their first 2 years of production typically carry a 20 to 30% price premium over established hardware. They also carry higher defect rates and less predictable repair costs, simply because the supply chain has not yet matured. Now, I know some of you are going to push back on this in the comments, and I want you to. The argument goes, if Tesla is using older hardware, the Model 2 will be obsolete faster. You are buying yesterday's technology at today's price. That is a fair challenge. Here is the counterpoint.
A chip that has already operated across millions of vehicles has had its failure modes identified and corrected. The repair infrastructure exists. Parts are in stock. The early adopter premium has already been paid by someone else. For a person who needs a vehicle to work reliably for the next 10 years on a predictable budget, that is not a limitation, that is a feature. The question is not whether you want the newest chip. The question is whether you can afford the uncertainty that comes with it. Tesla reportedly chose to base the Model 2 on their current proven hardware platform, the same foundation already deployed across millions of vehicles worldwide. That decision delivers three concrete benefits: stable component pricing because parts are no longer at an early adopter premium, higher real-world reliability because failure modes have already been identified and corrected at scale, and lower repair cost because shared hardware across multiple models keeps parts in stock and labor time short. The central computing system, the FSD computer and its associated hardware, represents one of the most expensive repair categories in modern electric vehicles. U.S. repair data from 2023 to 2024 estimates full system replacement at approximately $2,000 to $4,000, not including labor or diagnostic time. Tesla's current onboard computers are reported to maintain approximately 30 to 40% processing headroom above real software requirements. Headroom that exists to absorb software updates over years without forcing a hardware replacement. A battery management system that cannot handle updated software protocols can reduce battery lifespan by tens of %, which translates directly into range loss, reduced resale value, and replacement cost measured in thousands of dollars. The Model 2 is not built for the person who wants the newest thing. It is built for the person who needs the thing to work correctly 5 years from now without an unexpected bill that disrupts their retirement budget. And that brings us to one final category of hidden costs, the ones Tesla is reportedly engineering out before you ever sign a purchase agreement. According to automotive warranty data, camera and sensor-related failures account for roughly 15 to 20% of all issues that directly affect driver assistance systems. For a vehicle like the Model 2 that relies heavily on cameras as its primary sensing system, a dirty or malfunctioning camera is not just an inconvenience, it's a safety gap. Tesla is reported to be addressing this with a self-cleaning rear camera system, which reduces the driver's dependence on remembering to clean the lens after rain, mud, or snow. The camera-based mirror replacement also deserves a clear-eyed financial assessment. According to U.S. insurance data, replacing a modern powered side mirror can cost between $800 and over $1,500 after a minor impact, not because the technology is complex, but because the motor assembly, the heating element, the turn signal integration, and the body panel paint matching all stack into that bill very quickly. Replacing that mechanical system with a fixed camera reduces moving part count, eliminates several failure modes, and decreases the complexity that translates into labor hours during service. Every one of these decisions points in the same direction: fewer things to remember, fewer things to break, fewer things to explain to a service advisor while you wait in a lobby for a bill you did not plan for.
So let us come back to the question we started with. What does cheap actually mean when it comes to a car like the Model 2? Here is my answer, and I want you to write this down because it applies to every major purchase you will ever make for the rest of your life. A cheap car is not a car with a low price tag. A cheap car is a car with a low surprise rate. It means a door handle that works in January in Michigan. It means a body finish that does not require $1,200 of paint correction after 4 years of sun. It means hardware that absorbs software updates without forcing a $3,000 replacement. It means mirror design that prevents the fender scrape that becomes a $1,400 insurance claim.
The Tesla Model 2 is not trying to impress you on day 1. It's trying to protect you in year 5 and year 10. And for a man who has spent 4 decades making careful financial decisions, that is exactly the kind of engineering that deserves serious attention. Now here's my question for you, and I genuinely want your answer in the comments below. After everything we covered today, the materials, the door handles, the paint process, the hardware philosophy, do you think Tesla is actually delivering on this promise, or do you think this is still just marketing with better vocabulary? Say, "I believe it," or "I'll wait and see." There is no wrong answer. I read every single comment, and the honest disagreements are the ones that shape what I cover next. If this kind of analysis, reported numbers, clear trade-offs, no pressure, is the content you want to keep seeing, hit subscribe right now and turn on notifications. This channel exists for one reason: to protect your money before you spend it. And do not go anywhere yet, because the next video in this series takes the exact same cost-focused lens we used today and applies it to something even closer to home: Tesla's tiny house concept and why its structural design decisions could matter just as much to your financial security as any car you will ever buy. The numbers in that video surprised even me. You will not want to miss it. Drive safe, spend smart, and I will see you in the next one.